So the whole point in that warm-up today was because we are working with the quadratic formula. And when we work with the quadratic formula, what's that one piece in there? The radical. So we just wanted to have some practice with the radicals. Okay. Has anybody in here not already memorized the quadratic formula?
I forgot it.
You forgot it?
B plus or minus the square root of b squared minus 4ac all over 2a.
Bravo. Okay. So I'm not going to spend too much time doing the quadratic because I think everybody knows it pretty well. So things to remember are you need to be in standard form and set equal to 0 before you apply the quadratic formula. All right, so let's remember that. Standard form and equal to 0. Okay.
Standard form look like again? I kind of.
So that's this here.
Oh, is it? Okay.
Okay. Yeah. All righty. B squared minus 4ac. We see that's that piece that's under the radical. It has a very special name of its own. Who remembers that name?
Radicand.
Not radicand.
Radicand. Oh, the
Starts with a D.
derivative. Denominator.
Dis.
Distance.
No.
Discriminate.
Discriminant. It's the discriminant.
Discriminate.
Which one?
The one that's like equal to 0.
And standard form and equal to 0.
Oh.
Okay.
I thought that was like a backwards B. So ugly.
Okay.
Wait, I thought the B was for doing the radical.
It's the piece that's under the radical, but it's called the discriminant. Yeah. Okay. And so, just looking at the discriminant and evaluating it gives us some information about the solutions that we get. So, if b squared minus 4ac is equal to 0, again, that's that component that's under the radical, we would end up with negative b plus or minus 0. How many solutions are we going to get if we're doing plus or minus 0?
2. 1. Oh my
Right, so plus or minus 0.
2. Oh.
0.
No, you said it. I'm hearing both.
It's 1.
One solution, right? 3 plus 0 is 3. 3 minus 0 is still 3. There's only one solution, and it's going to be real. So one real solution.
Sorry.
If your discriminant is equal to 0,
Then there's one real solution.
you get one real solution. Okay.
Oh, I remember.
All right.
Oh, I do.
If your discriminant is positive, so now we have a positive number under that radical, okay, and we take the square root of a positive number, and then we get negative b plus or minus that positive number. How many solutions does that give us?
2.
2, and those are also going to be real. All right. Now the last case, what happens when our discriminant is negative? So that means we have a negative under the radical. So it's not going to be real. However, we do know how to find the square root of a negative value. So we're going to have an I in there. Yes, 2 imaginaries.
2 imaginary.
Yes.
Is there a possibility to have one real solution and one imaginary solution? Or
No.
Is that just...
No, not possible.
I was just wondering.
All right, so let's just jump in to some because I think everybody is already pretty good with these. Let's look at our first one here. 2x squared minus 5x plus 3. Okay, we always look to see if there's something we can factor out to begin with. Does anything factor out nicely?
No.
No. All right, so I'm going to go ahead and label my pieces. I'm already set equal to 0. My A term is 2, my B term is -5, my C term is 3, and so now this just becomes what I call a plug and chug problem. You just plug it into the formula and chug out the answer, okay? So x is equal to -5 plus or minus the square root of -5 squared minus 4 times 2 times 3 all over 2 times 2. And now we just need to simplify. So double negative, that becomes a +5 plus or minus the square root of, we get 25 minus 24 all over 4. Can we already tell how many solutions and what kind we're going to expect? Yeah, 2, and they will be real. All right, so continuing to simplify, I get 5 plus or minus the square root of 1 is 1 over 4. And that means 5 plus 1 is 6 over 4. And 5 minus 1 is 4 over 4. And these two simplify, so we get x is equal to 3/2 and 1. What's that?
I feel like you did that really fast, but like I understood everything. It's just
Yeah,
I feel like
last year I was just like taking like 20 minutes to do it one problem.
Well, this is why we prefer factoring, because the quadratic formula is tedious. It does take a long time.
Yeah, me too.
Because it's perfectly organized.
Okay.
Like all scales.
All right.
You have to solve it.
It's not like you have to win that one.
So what's the issue with B now?
Oh, it's not in standard.
You have to-
Okay, so first thing we would have to do is subtract 6x. So we get x squared minus 6x plus 3 equals 0. All right, I'm going to give you guys a minute to do that one.
Oh, like fire.
Yes, by yourselves. All right, so it looks like most of you are there. X is equal to 3 plus or minus square root of 6. Okay. Gold stars for everybody? Yes? All right. Okay. We'll do the next one together. Question?
Just to clarify, when you're dividing like how before it was 2 times the square root of 6 over 2,
Mm-hmm.
you can't cancel out inside of
No.
the
No, all your terms have to be either under the radical together or outside the radical. You
Okay.
can't mix them. So when you're here, and honestly, probably the most common mistake I would see here is students will do like, oh, 2 goes into 6 3 times
and not do the rest.
and not do the rest.
Okay, 'cause
Okay.
my problem is I always accidentally simplify inside of the square root.
Yeah, so remember, if you are dividing or multiplying terms, if one is in a radical and one's not, you cannot combine them. Okay. Okay, so our next one here. Is there anything we can take out to make this a little bit easier on ourselves?
Yes.
No.
Yeah.
No.
I thought there was something.
Nope. So again, I'm going to go ahead and set this up. A is equal to 4. B is equal to 4. C is equal to 5. All right. Plug and chug. X equals -4 plus or minus the square root of 4 squared minus 4 times 4 times 5 all over 2 times 4. Here we go. -4 plus or minus the square root of 16 minus, what do we get there?
-80.
80. What can we already tell about our solutions?
Less than 0.
It's less than 0, so how many solutions are we going to have?
We are going to have 2 imaginary.
2, and they will be imaginary. Okay, so we get -4 plus or minus the square root of -64 all over 8. So that's -4 plus or minus. What is the square root of negative 64?
Negative 8 or 8i.
Just 8i. So 8i divided by 8. Okay, and then you always want to remember when you're working with imaginary numbers, if you have a real part and an imaginary part, you always want to separate those two. So that's what a complex number is made up of, a real part and an imaginary part. So I'm going to go ahead and split this here. So x is equal to, we have negative 4 over 8 plus or minus 8i over 8. And can we reduce anything?
Yeah.
Yes. Negative 4 over 8 is negative 1/2 plus or minus what's left over with our 8i over 8?
I.
Just I. And there's our two answers.
So why did we split it into 2 parts?
Because there's the real part and then the imaginary part.
Wait, but negative 1/2 is an imaginary.
No, negative 1/2 is real.
I thought it was 2 imaginary numbers.
Well, because you have an imaginary being added to it, it makes the whole thing imaginary. But when you're writing a complex number, you separated it into the two components.
So there's always going to be one real and one imaginary.
Mm-hmm. But overall, yes, overall it's still imaginary. Okay. I'm going to let you guys do this one on your own. Okay, so it looks like most of you are there or you're on that last simplification step. So 2 over 5 plus or minus square root of 6 over 5i.
Can you put the
Okay.
I?
Yes. Yeah. Okay, so good job on that one. What'd you guys think of that fraction in there?
Cool.
Are we starting to enjoy fractions?
Yeah.
It's not that I
Except
mind
still, every time I
fractions.
get a fraction for an answer, I think I got it wrong.
Yeah.
No.
Or like an
Okay. And now our favorite.
That's actually my favorite.
Yes.
When it says calculator, you're like,
Okay. All right. So what we have here, I do have a charger.
yeah.
Okay. All right, the amount of trout, T in tons, caught in a lake from 1995 to 2014 can be modeled by the equation T equals negative 0.08 x squared plus 1.6 x plus 10, where x is the number of years since 1995. When were there about 15 tons of trout caught in the lake? Okay, so thoughts on what we would do to solve this?
Plug in 15 for 0 or
For T.
T.
15 for T, exactly, because we're looking at the when, and the when is the x, and the T is the amount.
So it's equal to 0.
Okay, so we get 15 is equal to negative 0.08 x squared plus 1.6 x plus 10. Okay, but before we can solve a quadratic, what has to happen?
Standard form.
Standard form, and we're going to subtract that 15 from both sides. So we get 0 is equal to negative 0.08 x squared plus 1.6 x minus 5. All right. And so again, we are always very excited when we have something that we can factor, but this is not one of those cases. And so the handy quadratic formula will help us here. So we get x is equal to negative 1.6 plus or minus the square root of 1.6 squared minus 4 times A, which is negative 0.08, times C, which is negative 5, all over 2 times negative 0.08. Okay, again, this is a calculator problem. I'm gonna... All right, so I usually don't do this in one step just because I feel like it's too many parentheses. So what I'm going to do is I'm going to take care of my denominator first. When we multiply 2 times negative 0.08, what do we get? Negative 0.16. Okay, so I'm going to, this is negative 0.16. Okay, so again, we're going to plug this into our calculator. So I have negative 1.6, and our calculator cannot do plus and minus, so we start with the plus, and then we do square root. So that's right here. So second, and then over the x squared. So square root, and we do 1.6 squared.
Don't you have to do parentheses on the
Nope. Well, I don't have a negative on it.
Oh.
If I had a negative on it, yes.
Okay.
Okay, so minus 4 times negative 0.08 times negative 5. Okay, so that's that piece there, and then we divide that by negative 0.16, and there's one answer.
Wait. What do we round to here?
Let's just go 3 decimal places. Okay, so there's one answer. So we got x is equal to, what was it, 3.875? So that was 1. Was it 7.6?
Because there's a 2 after.
Okay. Now, I don't want to retype the whole thing. Oh, thank you, right, it is 7.6. Okay, don't want to retype the whole thing. So I'm just going to cursor up, grab that equation again, plug it in, and then all I'm going to do is scroll back
That's so smart.
and change my plus to a minus now. There we go. There's that piece divided by negative 0.16, and there is my other answer, 16.124. Okay. Alrighty. So again, it's asking when were about 15 tons of trout caught. What do those 2 answers that we got represent?
Like the number of years and the time.
Okay. Number of years since. Okay. So then we could say approximately 3.876 would be for 4 years and 16 years after 1995. There were about 15 tons of trout caught.
How
Okay.
is it the same amount of, so like they didn't catch any fish for 16, or they,
No, they did, but
There's 15 tons of trout.
each year.
No,
it's
saying like
yeah, so there's a different amount every year, but
1999,
there were
I got, like, 15.
two different years that this
And
occurred.
like-
I thought this was
Yeah.
adding up until
So as you were saying, 1999
in 2005.
and 2011. 1999 and 2011. Okay.
I was like, there.
Okay. So what I want you to also realize is because this is a calculator problem, we can graph this in our calculators just as well. So if we look back to this piece here, How many equations is that really?
2.
There's 2 equations. This one here is y equals 15, and this one here is y equals, I'm not going to repeat the whole thing. Okay, so we can also graph this, right? So if I come in here and I go to my plots here, and I plug in negative 0.08 x squared plus 1.6 x plus 10.
Why 10?
That's the equation.
Oh, that's the original.
Mm-hmm.
Okay.
What should this look like when I do graph it? It's going to be a parabola facing down. Okay, so there's that one. And I'm trying to see when will it meet 15. Okay, so let me come in here to my graph. Oh, sorry, I have a stat plot on. Let me turn that off. It's a...
Wait, that happened to me earlier.
Okay, stat plot is now off. And let's go back to my graph. Oh, it's still in the wrong window. Okay, let's set up a window here. Let's see, what would be a good window? I'll start that at like -2. We found at least 16, so let me go out 25 years by 1. And I'll start that here. And I'll just put, I'll put 30. Okay, let's try that now. There we go. Now we can see there's the first equation, there's the second one. What would we be looking for here? Okay, so we can hit second and then trace and go down to intersect. And I'm going to find this one first. So it's asking which curve. Right now it's on my parabola, so yes, that curve. On the line, yes, that one. Take a guess, hit enter, and there we go. Am I supposed to be degree? Oh, it shouldn't matter for this one.
Oh, I have a question. Okay,
Yeah.
to help with factoring, how do you find like the factors of something on your calculator again? Like, don't you go like the y equals and then you do like divided by x?
Oh, I'd have to look up. You can do it in the table. Okay.
Yeah.
Yeah. Okay, so let me find this one. And so again, second, trace, intersect, and
Why do you have 2 equations?
because one of them is y equals 15 and one of them is the parabola. So that's the first curve. The second curve is the line. Hit enter, and there's our second solution. Okay.
I'm confused why the y-intercept is not 10 because that's what it is in the equation.
It is.
That looks like -5.
No, that's because you're looking at the line y equals 15 and not the axis. The axis is down here.
Axis?
No, this is y equals 15.
Oh,
How do you do that on
that
the...
would make sense.
How do you plug that in again? Like, how do you put that in?
If you hear the equations again. So 2 different
We
ones.
do have that.
Okay, so what would happen if we instead we graphed this equation down here? If we graphed this.
I don't know.
That's
I
just
didn't
a
understand why we
yeah.
got that.
Oh no, because that y-intercept would now be -5.
Okay, yes. And what would we be looking for in this one?
A maximum as well,
Maximums?
right?
Not maximums, but where x intercepts. Where does it equal 0? Exactly. Okay, so 2 ways to solve that. Now let me say, if you choose to solve this graphically, what all would you need to show?
Your work.
Which work specifically?
What you would plug into the calculator.
Okay, like you would have to sketch the graph. Does it have to be a perfect to scale graph? No, but you would have to sketch it. You would have to label which equation is what, and you would have to point that you used your calculator to find the intersections. Okay. Yes.
Whenever we plugged in the answer, we got 0.3878 and not
3.833.
like our decimal was moved over to the left one.
To
Like when we
okay, I'll have to come look at yours because I'm not
I
sure.
didn't get any of the answers.
In your calculator?
No.
Okay, we'll have to look at that. I'll look at it after what you guys plugged in so that we can make sure we finish this today. Okay, let's look at the next one. A juggler tosses a ball into the air. The height of the ball as a function of time is modeled by h of t equals negative 16t squared plus 30t plus 4. Does the ball reach a height of 25 feet? If so, when? If not, explain why not. So what is it we would need to do for this one?
Take the equation and let's plug in 25 for h of t.
Greater than or equal to 25. Right?
Well, just does it reach 25 feet?
Does-
So what are some of the things we could
equal
check?
to 25 then.
Okay, we can find the maximum.
Smarty.
Okay, so the maximum occurs where? At the axis of symmetry. So the axis of symmetry. So we would say t is equal to negative b. B is 30 divided by 2. And a is negative 16. Let's see. Those become positive. 2 goes into 30 15 times. So when we get t is equal to 15 over 16, what is that telling us?
That is telling us that that's a time.
That's the what?
Maximum.
Is that the maximum height?
I don't know.
That's the maximum.
That's the time that corresponds to the maximum height. So now we would plug that in. So we h of 15 over 16.
Is it just because this one's about
Nope, we had double negatives.
Time is always on the x.
So what's that?
Is it because it's about time and time is on the
Time is on the x, yes.
Okay, so that's the only thing.
15 over 16
But like
squared.
on other problems, it would just be the negative be over 2a.
Yeah, well, it's whatever variable is in there. Your axis of symmetry. It's always negative b over 2a. It's just a change of variable. Okay. Plus 4. Okay, so again, this is a calculator problem. This comes out to approximately 18 feet. So what can we say? Will the ball reach 25? No. It's about. Will not reach 25.
Feet.
Oh.
Because the max height is about 18 feet. Okay, what else could we have done?
We could. Well, I don't know. Earlier at the beginning, I was thinking if it was greater than or equal to 25,
Okay,
then
which means we would set it up equal to 25. You are correct.
well, why
If we
not
did
greater than
this,
or equal to?
Well, if it's just 25.
Yeah, but it could be 26.
well, if it doesn't reach 25, it may
It'll tell
not.
us if we
Yeah.
plug in 25, it'll
So
tell
if
us
it's
what
less
time
than
It's
25,
it's going
it
to tell
won't
us.
go.
Okay. So if we do this, I would have to move that 25 over, and I would get 16t squared plus 30. This would become minus 21 is equal to 0. And then
ABC.
if we went to solve this, let's look at our discriminant here. We would get the square root of b squared, so that's 30 squared, minus 4 times a is negative 16 times negative 21. Did anybody plug that in already?
No.
Yes. Wait, actually,
4 times 16 is 64. I think.
It's a calculator problem. You don't have to do it in your head.
Times 21.
Anybody get an answer?
Is it?
I tried to plug it in, but I don't think you can.
It's 13, 12. Oh, it's 1, 3, 3. Oh, you wanted me to do like the whole thing?
30 squared
Is
minus
100.
4 times
-13.
negative 16 times negative 21. What is that?
-4.
Okay, now we have a discriminant that's negative, and what do we know? It's two imaginary numbers, which means
It's less than 0.
okay. Well, it means that it's not the parabola does not reach 25 because we don't have a real value. Yeah, so that's another way to tell. Yes. So it's imaginary, so there is no real solution. Okay. So, does the ball reach a height of 10 feet?
Yes.
Okay, and how do we tell?
Because the maximum is greater than 10.
Okay, so we do know that it will reach it, and how do we find when that occurs?
Put 10 as y.
Plug 10 in.
For when the time for the maximum height was 15 over 16, does that mean like less than 1 second?
Yes,
Okay, so
yes.
So on like a test, if we just found like the vertex and like so we found the maximum and we didn't check it, would it still be correct, or do we have to check it?
Well, you'd have to show that you'd either have to show that you found the max height and it doesn't reach it, or you'd have to show this equation over here and say it doesn't work. There's no real solution. One or the other. Yeah, they both work just fine. Yeah. Okay. So again, this one we would just simplify. We get negative 16t squared plus 30t minus 6. Plug that into your quadratic formula. I'm not going to redo this one. And you should end up with about 1.647 and 0.22 seconds. Okay. So again, think about what's happening. We've got this parabola that is opening downward, and we are looking to see when does the height equal 10. Bless you. And so again, that occurs at these two places. This time here would be the 0.22 seconds, and this time here would be the 1.647 seconds. Okay. I want to move on to completing the square. How many of you have worked with completing the square? Okay.
I have.
Okay.
But I don't remember.
isn't it the one that's like 9x squared?
Like you have
And
to
then there's,
add
like-
another number.
You have to add another number.
To make them like.
Okay, so here is just a visual of what's happening when we say complete the square. All right. Okay. That's okay.
Yes, I get it now.
All right. Okay. I'm not going to read through the steps because I'm going to go through one and repeat the steps as we go along. The best thing is when we have an a equals 1 because it's one less step that we have to go through, but often a is not 1. Okay, so again, I'm going to sort of talk through the steps as we solve through one. So our very first one here is when we do have an a equals 1. So I have x squared plus 10x minus 6, and it's equal to 0. All right. So the first thing we're going to do is move the constant to the other side. So that's going to give us x squared plus 10x is equal to 6.
So we're moving it back over?
Yep.
Don't we usually want it equal to 0?
Not when we're completing the square.
Because then you have to.
Okay. Now what we're going to do is take our b value. What's our b value? Okay.
Like the half inch.
Yes. And we're going to do 10 divided by 2, which is 5. And then we're going to do 5 squared, which is 25. Okay, and then what we're going to do is add 25 to both sides.
Actually, wait, I kind of like this one. It's not that bad.
Okay.
So this is.
I don't know, because you just like little spaces.
Okay.
Where'd you get 5 from?
Where do we get you remember the B value?
B.
Where 2 from?
Okay.
You always divide by 2.
So we get x squared plus 10x,
Plus 25.
and then I'm going to add my 25. So plus 25
Plus 25.
and plus 25. Okay, so again, what we have done is we have forced the left side into a perfect square trinomial, which means we already know what the factorization is going to be.
5.
Yes.
That's so helpful.
X plus 5 squared is equal to 6 plus 25 is 31. And now that I have that, I can take the square root of both sides. All right, I have x plus 5 times x plus 5. So when I take the square root, it leaves me with 1x plus 5 equal to plus or minus the square root of 31, because I cannot simplify root 31. What's left?
I just subtract 5.
Subtract the 5. X is equal to negative 5 plus or minus the square root of 31. See? Was that so bad?
No, I mean I totally don't remember doing that.
Okay.
I don't remember doing these. I just remember the drawing that space.
Yeah, same. I remember just drawing like a blank.
Like the underline.
Yeah.
That's very vivid in my mind.
On the exam,
Okay.
I remember just drawing blanks, but I didn't know what to put in them, so I just had to guess.
All right, let's look at them when A is not 1.
Oh gosh.
She's like, right.
I have a question.
Yes.
So after the x plus 5 equals plus or minus 31.
Mm-hmm.
Oh wait. Oh sorry, I just took the thing off of there and then I was confused on why it was back on, but it was never off.
Okay.
The radical.
All right. So A is not 1. Of course, and we always look to see, is there anything that we can factor out easily? Nothing factors out easily here. But what we are going to do is factor out our A value, because it's just easier if you do it up front. So I'm going to factor A to start. So that leaves me with x squared minus 2x plus 7 halves. Okay.
Yeah, why can't it?
Yes.
So if it was hypothetically like equals 2, would you factor, would you
Equals-
like make it into 1?
If it,
Oh, you would minus it before.
which piece? I'm not sure I understand what you're asking.
Never mind.
Okay. Now, what happens if I divide both sides by 2?
Then you just do x squared.
Cancels out.
And then it's still equal to
Okay,
0.
because
So that
0
would be
divided by 2 is still going to be 0. So this term is gone. All right. So now, remember, I'm trying to get this by itself. So if I divide both sides by 0, I'm still going to get x squared minus 2x plus 7 halves is 0. Okay. All right, so what I'm going to do is I'm going to set myself up by leaving some space here because I know I'm going to complete the square. I move the 7 halves to the other side, so negative 7 halves. Yes?
Does it mess the problem up if you move 7 to the other side, like while it's still 7, like at the very beginning before you factor the 2?
It means that when you start multiplying stuff back in, you have to take into account the other 2. So it's easier if you just do it up front and move that term out of the way, even though it gives us that fraction. So, okay. What is my B value?
2.
Negative 1.
B is equal to negative 2. What do we do with negative 2?
Divided by 2.
Divided by 2, which is negative 1. What do we do with negative 1? We square it. We get 1. We add 1 to both sides. Add 1 plus 1.
And if it was negative 1, you would subtract 1 from both sides.
Well, you're still squaring it. So no matter what, it's always going to be positive. Yes. Yes, that's the only thing that changes. Again, you have forced the left side into a perfect square trinomial, so you already know what it factors into.
1 minus -1. Oh wait, that's
X minus 1 and X times.
And again, this time it's minus because that middle term is a negative. Okay, equal to, what happens when I add -7/2 plus 2/2? -5/2. Okay, then we have to take the square root of both sides. So that leaves us x minus 1 is equal to plus or minus. I have a negative inside.
Oh, I.
So I am going to have an I, and then I'm going to have a square root of 5 over a square root of 2.
And you can't have a square root.
And we don't like radicals in the denominator.
Right.
Yes. So we multiply.
Totally remember this now.
Okay, so let me come over here. In the end, I have to add the 1 to the other side. So I get x is equal to 1 plus or minus square root of 5. It's still there. Square root of 5 times square root of 2 is square root of 10 divided by 2, and my I is still there. I never went away.
Okay, I got really lost.
Why did you multiply
no
square
math.
root of 2 and times?
To rationalize the denominator so that we didn't have a radical in the
You
denominator.
can just do that.
Yes.
Yes.
Yeah, she can.
The square root of something times the square root of something equals.
Yes, Jane.
So the I thought it would stay on the top of the fraction because wasn't that what
Well,
the negative was?
it technically is still on the top. I just have it over on the side. It means the same thing.
Okay.
Can we leave it on the top?
You can leave it on the top. That's fine. What you don't want to do is write it small so that it looks like it's under there.
Oh, because that's false.
Yes, that would not be true. So that's the only thing you have to be careful with.
Wait, but
Yes,
why
you can
would
put
that
on the
not
top.
be true again?
What?
Why would it not be true?
Because I doesn't belong in the denominator. Yep, should be in the numerator. Okay, how about you guys try the next one? So it looks like most of you are pretty close.
No,
Ran into a couple little mathematical errors, but that's okay. 1/2 plus or minus 2i. Okay, I just want to make sure we get through this last one because it's our favorite type of
application.
Yay! Okay, so in this one, some sand art, I need a thinner pen. Some sand art contains sand and water sealed in a rectangular glass case. When the art is turned upside down, the sand and water fall to create a new picture. This particular glass case has a length 8 centimeters longer than the height and depth of 1 centimeter. Okay, so I'm going to sketch my rectangular case here. And again, it has a depth. So let me put that in. Okay, not quite a cube, but all right, so we'll call this the length, and we'll call this the height, and we'll call this the depth. Alrighty, we know that the depth is equal to 1, and we know that the length is 8 centimeters longer than the height. So h plus 8 for this, and we know the volume of the whole thing is 768 cubic centimeters, right? So volume is equal to the length times the height times the depth. Alrighty, so we have 768 is equal to the length we said is h plus 8. The height is still h, and the depth is 1. Alright, what kind of equation did we create?
A two variable.
Three variable equation. Three system equation.
768 is equal to h squared plus 8h. What is it?
It's something that you can. Now you
Parabola.
can complete
Yes.
How did you
Right.
Yes.
I am confused how you wrote out the equation.
I wrote this piece down here as my length. I wrote this piece as my height and this piece as my depth. Okay, and then we were told that the length was h plus 8. And so we plugged in that for the length. The height is just the height.
Oh, that's
And the
an
depth
H.
is
I'm sorry.
1.
I thought that was a
Yes.
W, and I was kind of confused. So we got that.
Okay, so can we complete the square on this? Yes. All right, so we get 768 plus, I'm going to leave some room there. I have h squared. What's the beauty of this one? What is a?
1.
A is 1. Plus 8h. What's half of b?
4.
4. What's 4 squared?
16.
Add 16 to both sides. Okay, my right side factors into
H plus 4.
h plus 4 squared. And what do we get on the other side?
784.
784. Okay. Who knows that off the top of their head?
Me.
You do?
It's, I don't know.
When you take the square root.
12.
It's should be 28.
Oh, that's what I said.
That's what I really was.
You were not.
I actually was because I knew it had to be below 30.
Okay. Oh, and remember it's going to be
Oh,
plus or minus.
You said 12.
So that means we get h is equal to 28 minus 4 or negative 28 minus 4. Alrighty, but what do we know about a height? Cannot be negative, so we know it's not that. What is our height?
24.
24.
Height is equal to 24. And if height is 24, what's our length?
Oh, plus 8. Plus 8.
Plus 8, 32. Okay. So what was the last question? Find the dimensions of the glass case. Okay.
We did.
The dimensions, again, height, it was depth, was 20, it was 1. Height is 24 centimeters, length is 32 centimeters, and the depth was given to us as 1. Yes.
So I understand like all of that, like that makes sense. But at the beginning, like when we wrote out in the parentheses, how did we go from that to the equations? Because if you multiplied like those, how did you get like just h squared plus 8h?
Because we have 1, it's just 1, so that goes away, and then we're just distributing this. H squared.
But like h times 1, isn't that h?
Yeah.
So don't we get another h?
No, we don't get another h. H times 1 is just h. You don't, it's not distributing through.
Oh, I'm sorry,
Okay.
I'm an idiot. That makes sense.
Okay, so how are we feeling about completing the square?
Good.